Hello friends, so here in this problem we have to evaluate limit n tends to infinity 1 upon n square plus 2 upon n square plus 3 upon n square plus dot 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 plus the last term is n minus 1 upon n square. Now before starting with the solution, if you'll observe the given limit, so here we have n tends to infinity, and whenever we have n tends to infinity or any other variable tends to infinity and we have infinite limit, then that time we use this substitution and we put that variable, let's say here it is n equals to 1 upon t, and by using that substitution we solve the limit. Now before substituting n equal to 1 upon t, if you'll observe, then here we have series, and if I'll simplify this series, then here I'll get following term. So I'm assuming this limit as L, so limit n tends to infinity. So let's see what we are getting. So 1 upon n square plus 2 upon n square plus 3 upon n square plus so on till n minus 1 upon n square. Now if you'll observe the denominator of all the terms, then it is n square. So I'll write it once, so that will become 1 plus 2 plus 3 plus so on till n minus 1. And if you'll observe the series which is in the numerator, then you can say that this series is in AP, that is arithmetic progression, and the difference between any two terms is 1. It means that difference is constant. So since this series is in arithmetic progression, we can substitute the formula for this. Now what is the formula? So let's understand it. So the formula for the series 1 plus 2 plus 3 till n, that is addition of numbers till n. The formula for this is n into n plus 1 upon 2. So if series in arithmetic progression, and if we want the summation of the terms, or I'll say of the n terms, then the formula is n into n plus 1 upon 2. Now if you'll observe the term which is there in the question, then here the last term is n minus 1, whereas in the formula the last term is n. So since our last term is n minus 1, in the formula we will substitute n minus 1 everywhere. So wherever we find n, we will substitute it by n minus 1, because our last term is n minus 1. So this numerator will become L equals to limit n tends to infinity. This n will become n minus 1 because last term is n minus 1. So n minus 1. In the bracket we will get n as n minus 1 plus 1. So n minus 1 plus 1 upon 2. So that is the substitution for this series in the numerator. Whole upon, we have n square in the denominator, so it is as it is. Next, if we'll solve this, we'll get limit n tends to infinity. Now we can cancel this plus 1 and minus 1. So here we'll get n. Then this 2 is in denominator, so it will go here with n square, and in the denominator we will get 2n square. In the numerator n will remain, and with n minus 1 will remain. Now if we'll solve this, then here we'll get, therefore L equal to limit n tends to infinity n square minus n upon 2n square. And if we'll divide it separately, then we'll get n square upon 2n square and n upon 2n square. Therefore L will become limit n tends to infinity n square upon 2n square minus n upon 2n square. Next, we can cancel the n square and n square term. So we'll get limit n tends to infinity 1 by 2 minus n and n cancel. So here we'll get 1 upon 2n. Now here, as we have simplified the given term, we can substitute n as 1 upon t, because here we have infinite limit, that is n tends to infinity. So therefore here I'll say put n equals to 1 by t. So as we substitute 1 by t, here since n is infinity, this term will become infinity is equal to 1 by t, and we know that we can get answer as infinity if the denominator is 0. So it means t has to be 0. So here I'll say as n tends to infinity, then t tends to 0, because if t tends to 0, then 1 upon 0 will become infinity. So hence this limit will change, or this function will change from n domain to t domain, as well as the limit will change from n to t. So therefore L will become limit t tends to 0, 1 by 2 as it is, since there is no n term, minus 1 by 2, and this n I can replace it by 1 by t, so that will become 1 upon t. Now this t will go in the numerator, so therefore here we will get L equals to limit t tends to 0, 1 by 2 minus t by 2. And now as we got the finite term here in the limit and the function is algebraic, we can use the direct method. So by direct method I'll substitute t equals to 0 directly in the function, and therefore we'll get L as 1 by 2 as it is minus 0 by 2 by direct method. And if we'll evaluate this, then 0 upon 2 is 0, and here we'll get answer of L as 1 upon 2. So the value of the given limit is 1 upon 2. Thank you.